Now we're on to section 3.4, which is to solve multi-step equations that have variables on both sides. As you can see in this problem that we have in front of us, there are x terms on both sides of the equal sign, and we either want to get x to the left or x to the right. It's usually easiest to move x left, but you can move it whichever way you want. We're going to use inverse operations to help us. So I'm going to subtract 4x on both sides first, so that I get 7 minus 12x equal to negative 17. And then I'm going to subtract 7 on both sides so that I move the constants together and have negative 12x equals a negative 24. Then I can divide by negative 12 on both sides and come up with x equal to a positive 2. If you had started moving the constants first, that's fine, and then move the variables, it does not matter which one. I think on the next problem, I'll move things along the way, probably different than this one. So on this problem, we have 9x equals 6x plus 4, or excuse me, 6 times the quantity, x plus 4. So first we have to do a little distributive property. 6x plus 24 equals 9x. And now the variables are on both sides, but we don't have a constant on both sides. So we need to move this 6x over to the other side by subtracting 6x. So we end up with 3x equal to 24. And then we can divide by 3 on both sides and find out that x equals a positive 8. Here we have variables on both sides, and we need to take care of the distributive property. So let's just go ahead and write that left-hand side, 3 minus 4x. The right-hand side, let's take care of the distributive property, 5x minus 15. And I'm going to start out moving the constants first this time instead of the variables. So I'm going to subtract 3 on both sides. So I got negative 4x equals 5x minus 18. And then I'm going to subtract the 5x on both sides and get negative 9x equals negative 18. We will divide by the negative 9 on both sides of the equation and find out that x equals a positive 2. Here I moved the constants first. That first example we worked on, I moved the variables first. It doesn't matter. The second problem though that we were looking at, going back just one, the only thing I could move was the variables because there was only one constant. So keep that in mind. Look at what's in your problem. Let's go on to problem number 4. We got 20 plus x equals 4x minus 7. This time I'm going to move my x over to the right and have 20 equals 3x minus 7. And then I can add 7 to both sides and have 27 equals 3x. And then divide by my 3 on both sides and find out that 9 equals x. Notice how when I moved that x to the right, my x became a positive number. It was just easier to work with than with all the negatives. I could have moved the 4x to the left first instead. 9 minus 3x equals 17 minus 2x. So again, I'm going to add 3x to both sides because that will give me a positive x on the right-hand side. Then I can subtract 17 on both sides and end up with a negative 8 equals x. If we had not done it that way, let's say that we instead added 2x to both sides and we had 9 minus x equals 17, then I would subtract 9 on both sides and have negative x equals a positive 8. Well, that negative x, hopefully you all know there's a negative 1 in front of that x. So that means I technically am dividing by a negative 1, and I will get the same answer. X is equal to a negative 8. As we work on this problem, we see that we have a 1/4 times of something in parentheses. 4 divides evenly into 16 and it divides evenly into 60. So what would be very nice and easy to do is to distribute that 1/4 in and not have to multiply by the reciprocal on both sides. So we'll have 9x minus 5 equals, it's really 1/4 times 16x, and it's 1/4 times 60. So as we're doing that, 1/4 times 16x is 4x, and 1/4 times 60 is 15, and we still have the 9x minus 5 on the left-hand side. Now we can subtract our 4x, and that'll give us 5x minus 5 equal to 15, and we can add 5 to both sides and have 5x equals 20. And our last inverse operation is to divide by 5 on both sides, so we find out that x is equal to 4. What happens when all of the variables drop out? Well, let's see how they do drop out. We have a couple like terms here on the left-hand side that we need to add together. So 6x minus 2x gives us 4x plus 5 equals 4x plus 5 on the right-hand side. If I start moving my x's first, what happens is my variables drop out on both sides, and I'm left with 5 equal 5. No variables at all. When this happens, we have to think. This is a true statement. And since this is a true statement, we get to say that all real numbers will work in this problem. And the way that we say that is by making a capital R. That stands for all real numbers. Capital R. You can print it. You can print it like this. That's fine. I did a scripted one. Very pretty. On this problem, let's check out what happens when we add these together. They're like terms. That gives us a negative 8x plus 1 equals 3 minus 8x. If we're to add 8x to both sides, again, our variables are going to cancel out completely, and we're going to be left with 1 equal to 3. Now I want you to think on this one. Is that true or false? That is a false statement. And since that's a false statement, there is no solution to this problem. No matter what we do, there is no solution. So you can write no solution. I will accept no soul as an answer as well. When the variables drop out, please remember that there's an infinite number of solutions, so we say that that solution is all real numbers, that capital R. And if it is a false statement, like 0 equals 5, then there is no solution. So on the 5 equal 5, there's a whole bunch of solutions, an infinite number of them. What are they? It is all real numbers, capital R. And finally, a story problem. You bought 5 t-shirts online and had an $8 shipping cost. Your friend bought 7 t-shirts online and had a shipping cost of $2. You and your friend spent the same amount of money. It's important to notice that you and your friend spent the same amount. So that means that you are equal to your friend in terms of how much money you spent. Well, you bought 5 t-shirts and there was an $8 shipping cost. So 5 t-shirts times however much they cost plus $8 for shipping. Your friend bought 7 t-shirts and they cost the same amount because you guys bought the same kind, and there was a $2 shipping cost. We need to find the cost of 1 t-shirt. Well, we've got an equation here with variables on both sides. So let's go ahead and subtract 7x on both sides. Or would it be better to subtract 5x? I think it would be better to subtract 5x. That way I have a positive x when I get done. We have 8 then equal to 2x plus 2. Subtract 2 on both sides and get 6 equal to 2x. When we divide by 2 on both sides, we find x is equal to 3. And x is the cost of the shirt. So we're going to say $3 for every shirt. And then we're done with our story problem. Again, if you're having troubles, come in and see me, ask some questions. Good luck on your homework.